Okay, so this last extra question here, I'm going to make this very brief because the answers are, I'm providing the answer, answer key for all of these. The number of vertices, okay, let's call this V. And I have drawn what is called the tetrahedron, that's the first one, and then the cube, that's the second one. And then I didn't tell you this, but there's another one called an octahedron that is got 8 sides, 8 faces. And then this last one that I drew is called a dodeca. You know what dodeca means? Dodeci. That's an English, Italian word for 12. I remember I had to pay 12 euros and the bus driver in Italy says dodeci. And I knew what that means because I knew what a dodecahedron was. Okay, that's a 12-faced object, okay, which is very dear to my heart because I, as a grad student, had to draw this dodecahedron many times in my research. All right, so the number of vertices here, if you count the corners here, you have 4, right? 4 tetrahedron. Number of edges is you have 1, 2, 3, 4, 5, 6. You have 6 you can count, right? And number of faces, you have 4 faces. All right, so it's 4, 6, 4. Of course, you don't see a pattern yet. All right, when you go to the cube, you have how many? You have 4 corners on the top here, 4 corners on the bottom. It's 8 vertices. Edges, if you count, you have 4 on the top part, 4 on the bottom, and then 4 going up and down like this. Okay, so that would be 4 plus 4 plus 4, that's 12. And then you have the number of faces, which is of course 6, just like, when you roll a die, you have 1 through 6, right? And it doesn't seem like, maybe you see a pattern here. All the numbers we have seen so far are even numbers, but the vertices and faces here, 4 and 4, that's 6 and 8. How about octahedron? Go ahead and count this. There's a vertex on the top and vertex on the bottom, and then you have 4 vertices sort of in the middle, so that's 6. And then the number of edges, in this case, you have 1, 2, 3, 4, 5, 6, 7, 8. And then you have 4 more, so you have 12. And then you have the number of faces. Oops, yeah, okay. So this little over here. The number of faces in this case, you have 1, 2, 3, 4 on the top and 4 in the bottom, so it's 8. Okay, all right. You notice here, if you add the vertices and faces, that's 8, and 8 minus 6 is 2, right? So if you add the vertices and faces here, that's 8 plus 6, that's 14, but a number of edges is exactly 2 less than that, okay? And here, it's the same thing. Look, this is exactly the opposite of these. This is 8, 12, 6. This is 6, 12, 8. And then finally, for dodecahedron, this is hard to count. You actually should have a basic dodecahedron here. But vertices, you actually have 20 vertices, 20 corners, okay? So you can count 1, 2, 3, 4, 5. And then on the opposite side, you have another 5. And then here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 5 in the front, 5 in the back, 10 sort of in the middle. That's 20 vertices. If you count the edges, you will see that there are 30 edges. And then if you have, of course, it's called the dodecahedron, so that's 12. Okay, and the pattern that people have recognized for over centuries really is if you add the vertices and the faces, it'll be exactly 2 more than the number of edges. So if you subtract the number of edges, you will always get 2. Okay, so this 2 is a constant, regardless of what kind of solid you have that have vertices, edges, and faces. The number of edges is always 2 less than the sum of the number of vertices and the number of faces. This number 2 is called the Euler Characteristic, named after Leonhard Euler, a Swiss mathematician. But this is called the Euler number of a solid like these. Okay, and the Euler number changes if you have a big hole in the middle of a solid, or if you have 2 holes in the middle of a solid. But this is one of those cool things that's true with all kinds of solids, okay? And you can, and a soccer ball is actually different, because if you look at the soccer ball, I didn't draw a soccer ball. You may have thought this last one is like a soccer ball. It's sort of like it, but if you look at a typical soccer ball, it has let's see, it has pentagons, the 5-sided, faces surrounded by, a bunch of hexagons. Okay, so there will be 5 hexagons around each pentagon in a soccer ball. And if you count the number of vertices, edges, and faces of a real soccer ball, and I encourage you to do that if you have a soccer ball around your house. I have a whole bunch because I used to play soccer. And but anyway, you will see that the number of vertices plus the number of faces minus the number of edges will again be 2. Okay, you can't do anything to change this fact. And so that's another pattern you see here in light of mathematics. And this actually leads to more advanced mathematics, and there are many things you can do with this number. All right, so that's it. Again, work on your worksheet number 4. And next time we'll see that'll be lesson number 5 when we're going to chapter 2. All right, until then, have a great day, and I will see you then.